Okay, so in this video I just want to talk about one of the command line features of Wiggle, which is this compilation of CryoDragon results or CryoSpark 3D variability analysis results into a single NumPy binary. So you could also do this in Python, but Wiggle just provides an easy means to do this. So one of the benefits of this is you have a more compressed file format, which takes up less space and it's easier to share amongst colleagues, but it also hopefully makes it easier for you to deposit your analysis results because you no longer require the CryoSpark project or any of the CryoSpark backend in order to visualize and analyze these results. You can simply share it to anyone with CryoSpark, with Chimera X and Wiggle installed. So it's pretty simple. You use the Python that's shipped with Chimera and then the path to this wiggle.py file, which is located under source. And so if I just go user local programs, Chimera X bin Python, and for me, my Wiggle is in my projects directory, source wiggle.py. Okay, so this is the command line mode. You can see some help message here. The operating mode is CryoDragon or CryoSpark 3D variability analysis, and this is a future project which I hope will happen sooner rather than later. So once the algorithm details of the 3D Flex is announced. So at the moment, Wiggle only deals with CryoDragon and 3D variability analysis. So this is a bit cumbersome to write out every time, so I like to just define an alias in my bash file called Wiggle, which just essentially is a shorthand for that full command. So Wiggle help gives me the same thing. All right, so Wiggle CryoDragon help, what do we need? When you run a typical CryoDragon analysis, you have three main files that are important: a config pickle, which contains important information for CryoDragon to be able to render your volumes, information about how the network was trained and certain parameters, the weights and biases of the CryoDragon model encoded in a pickle file, and then also the Z vectors that encode the latent space. So there you have every particle a Z vector with, say, in this case, I think it's 8 dimensions for each particle. Wiggle will also ask you to give it the pixel size, and this is just a necessary additional piece of information such that the volumes are rendered on the correct grid so that they're the correct size for atomic models and such. Okay, so we need the config, the weights, the Z space, the pixel size. I think it's around 2.3, but I'm not sure. It's inconsequential for this tutorial, but obviously that needs to be correct for your that needs to be correct if you deposit this data or you share this data, otherwise your colleagues will be rendering volumes on the wrong grid size. And then the output file is just a NumPy compressed binary. And so in the context of CryoDragon, this isn't that much smaller than the sum size of the config weights and latent space. It is a little bit smaller, but Ellen's done a really good job of writing a very compressed, succinct format for this variability analysis. So when that's done, we should have a slightly smaller single file format. Okay, so we shaved off about 80 megabytes, not that much. But it is more convenient to deposit a single file and share a single file amongst colleagues. This also has the pixel size encoded into it. Now you can also read this in Python. It's just a compressed NumPy binary, so there's nothing fancy about it. Python import NumPy as NP. We're going to NumPy load our single file format, allow pickle True. And then we can get information like the pixel size. If we ask for config, it will return all of the metadata for the config. So you can also pass those files yourself. It's just a compressed NumPy array. It's nothing fancy. Okay, so that's for CryoDragon. Let's do an example for CryoSpark. Okay, so same deal. Wiggle help. This time we want the 3D variability analysis mode. And so for CryoSpark, you need the basis or consensus map. You need all of the component maps. So this is a list of component maps. You need the particle metadata file, and then you have to define an output. So in this directory, I have a typical output from a CryoDragon 3D variability analysis. There's the basis map. That's the first file we need. There are the component maps. Oops. This is the second set of files we need, components. So here we can provide a wildcard that will get all of them, particles. Now if you want to export subsets of particles, it's worthwhile also keeping the pass-through file, but this isn't necessary for Wiggle to render volumes. It's only necessary if you want to export subsets for further analysis. Output, and let's just call this CryoSpark project 44 job 320 npz. So once again, Wiggle will take all of those files and compile them into a single file format of a compressed NumPy binary. And in this context, we usually get quite a significant gain in file size. So if we have a look at all the MRC files and the CS file, that's about 0.5 MB, but the compressed NumPy format is about 100 MB. So that's about 20% of the original size. So that's really good. We can share that with our colleagues. So those two files are readable by Wiggle, and you can also read them in Python if you wish, or if you want to pass those files for some other reason. That's it.